6 identical gray FCC units are secured within specialized thermal conditioning chambers, preparing them for the
Advanced Jet Trainer Digital Flight Control System Programming and Testing. A robotic unit applies high-pressure air.
The Process A zone is pressurized and monitored for microscopic particle counts, ensuring stringent aerospace standards. The programmed FCC units are routed to the hardware-in-the-loop simulation bay. Robotic arms carefully. The programmed FCC units endure simulated exposure to extreme humidity and corrosive salt spray.
System initializing. Flight control online. Radar sweep active. Target acquired.
This advanced digital flight control system for the Hongdu L-15 Falcon is secured by a robotic arm.
The Advanced Jet Trainer digital flight control systems undergo final processing before automated stacker cranes move the packaged FCC units into cold storage.
The specialized cooling jackets and programming interface cables are systematically cleaned, sterilized, and stored.
Advanced digital flight control systems require absolute precision. The automated drone confirms the zero overlap protocol is now in effect. The high-intensity ultraviolet light array cures the potting compound, rapidly hardening the internal structure to secure the FCL data permanently. A diamond-tipped engraving machine etches the final classification code onto the master data archive drive, ensuring permanent physical traceability. A robotic spray applicator seals the archive drive with a military-grade anti-corrosion coating, ensuring longevity in diverse storage conditions. For the L-15 Falcon's flight control system, a specialized robotic welding system creates an irreversible hermetic seal on the titanium containment box. The exterior of the sealed titanium box is coated with a proprietary anti-radiation paint. The robotic painter
The L-15 Falcon's flight control system undergoes cryogenic testing, demonstrating the resilience of the electronics in extreme temperatures as frost rapidly forms.
The titanium box is moved into the vault and surrounded by thick shielding materials to protect against EMP exposure.
A highly durable, radiation-resistant label is applied to the titanium shielding.
The density map confirms the archive drive's integrity. No foreign objects detected.
The advanced digital flight control system undergoes final inspection. The shielded titanium box is transferred onto a heavy-duty, tracked robotic vehicle.
The archival FCL code confirms the stability baseline.
But are these curves within the L-15 envelope?
We'll verify the new control laws with a simulation now.
The archival drive serves as the ultimate source of truth for configuration control and system verification.
This drive stored the entire flight control system for the L-15.
It's incredible how they preserved it.
Look here at the triple modular redundancy architecture. This is what makes the L-15 system so robust.
The strategic importance of this archive cannot be overstated. With these redundant locations, our data integrity is absolute.
The intricate detail of the etching is clear under high magnification, demonstrating the permanent physical logging applied